Okay, so if you could turn to page 5 of your packet, we're just going to, this is kind of part 2 of system of equations. We're going to solve more systems algebraically. All right, so if you guys recall from yesterday, the first thing you want to do is you want to get either x or y by itself in one of the two equations. The only thing is, if there's a square like this, x squared or y squared, I wouldn't recommend these being the one of these being the variables that you get by itself. It definitely makes it a lot more complicated. So I would just get either x by itself in this first equation or y by itself in this first equation. Now, I'm actually going to get the y by itself because I'm just kind of looking ahead. And, well, let me just show you. Okay, so let's get y by itself in this first equation. So I'm just going to do this off to the side. Let me do it over here. All right, so we have 3x plus 4y equals 25. Okay, so if I want to get the y by itself, I'm going to subtract 3x from both sides, which leaves me with 4y equals, it really doesn't matter how you order this. If you want to write negative 3x plus 25, you can do that. You can even just leave it as 25 minus 3x. Okay, it doesn't matter, you get the same answer either way. And then we're going to divide both sides of the equation by 4. So that leaves me with y equals. Now, this is personal preference. This is up to you. You can leave this as 25 fourths minus 3x over 4. You can leave it as one big fraction, or I find if you can, if you get terminating decimals, I find most people like to use decimals when we do this. But that's your call. I personally like fractions, but I find most, students in this course prefer the decimal. So I'm going to change these decimals. So 25 divided by 4 would be 6.25. So let's make that 6.25. All right, and then I'm going to take this minus sign right here and bring it down. And then 3 divided by 4 is 0.75. So we could write this as 0.75x. Again, if you left it as fractions, that's totally fine. Okay, so now that we have y by itself, we're going to take this right here. We're going to take what y is equal to, and we are going to substitute it in for y into the other equation. Okay, so instead of having x squared plus y squared equals 25, we're going to have x squared plus this squared equals 25. So x squared plus, I'm going to put this all in parentheses. Okay, and square it equals 25. All right, so this is the equation that we're going to be solving. All right, I'm going to kind of start on a blank page because I don't think I'm going to have enough room down here to solve this. I think it's going to be a little bit longer than that. Okay, so first, if we know that this right here is being squared, let's just take it and write it out twice. Okay, so I brought down the x squared. Since this was being squared, I took it and wrote it out twice, and then I brought down the equals 25. Now, what we're going to have to do is, since we have a binomial times another binomial, we are going to have to double distribute. We're going to have to distribute the 6.25 to both terms, and then the negative 0.75x to both terms. All right, so let me first take this x squared here and bring it down, and let's just start double distributing. So 6.25 times 6.25 is positive 39.0625. And then 6.25 times negative 0.75x is negative 4.6875x. All right, so then we're going to distribute the negative 0.75x to the 6.25, which is going to be exactly the same thing as the last term, so negative 4.6875x. And then negative 0.75x times negative 0.75x is going to be a positive 0.5675x. 6.25x squared, right? Because x times x is x squared. And then we'll just take this equals 25 right here and just bring it right down. All right, now we have to combine our like terms on this side of the equation. And we also, since we have x squareds in our equation, we want to get one side of the equation equal to 0. So I'm going to kind of do that all in one step. I'm going to subtract the 25 from both sides so that the right-hand side is equal to 0. And I'm going to line that up under this other numerical term there. And so on the right-hand side of the equation, we have equals 0. And now I'm just going to combine my like terms. So let's see, we have x squared, which combines with the 0.5625x squared. So that'll give us 1.5625x squared. And then we can combine these two terms right here with the x's on them. Okay, so if we combine the negative 4.6875x with the other term, that will be negative 9.375x. That is a 3. Sorry, that's really sloppy. It's kind of hard to write with the stylus. And then I'm just going to combine my numbers here. So if I take these two numbers and combine them, they wind up being a positive 14.0625. All right, so here's our equation. It's a little sloppy. It has decimals, but I'm just looking at it. Since our leading coefficient is 1.5625, it's probably a good idea to see if that divides evenly into the other two numbers, and luckily it does. So I'm just going to divide both sides of the equation by that leading coefficient. And that's going to make our life a lot easier. Okay, so let's start here. So this first term, right, the 1.5625x squared divided by this, I mean, basically these two numbers are going to cancel off, and we could bring down the x squared. All right, then if you do negative 9.375x divided by this denominator here, you will wind up, actually this divided by this is just minus 6. So we wind up with minus 6, and I'll bring down the x. Then we're going to keep going. This term divided by our denominator is positive 9. And on the right-hand side of the equation, 0 divided by this is just 0. All right, so from this point, it should be fairly easy. We're just going to factor. So that factors to x minus 3 times x minus 3. And when we make a t-chart, we wind up with x equals positive 3. And you're going to get the same thing over here. I'm just going to write same. Okay, you don't have to rewrite it. All right, so now what we have to do is we have to find the y value that goes along with the x value of 3. Now, if you recall in the very beginning of the problem, we took that first equation and solved for y, and we wound up writing it as y equals 6.25 minus 0.75x. I'm going to use this equation to help me solve for the y value that goes along with an x value of 3. All right, so I'm going to write y equals 6.25 minus 0.75, and I'm just going to take this 3 and substitute it in for the x. Okay, so y equals, now if you figure out what this right here is equal to, it's just equal to positive 4. So when x is equal to 3, y is equal to 4. So that is going to be our one and only point of intersection here. I mean, if you were to take, this other side and solve it, you would wind up with the same point of intersection. So there's only one point of intersection here. So this is our answer. Okay, the other one we're going to look at is number 8, and then you're going to try out numbers 5, 7, and 9 for homework. Okay, so again, you want to get x or y by itself in one of the two equations, and if you see a squared on either of the variable terms, I wouldn't get that variable by itself. So we could either get x or y by itself. It totally does not make a difference. It's your call. All right, so I guess I'll just get the y by itself. So I'm going to subtract the 2x from both sides of the equation. And again, it doesn't matter. You could get the x by itself as well. All right, so that leaves us with 2y equals. And you could either write this as 10 minus 2x or negative 2x plus 10. I'm just going to leave it as 10 minus 2x. Doesn't matter either way. And then when we divide both sides of the equation by 2, we get y equals. All right, so 10 divided by 2 is 5. And you could bring down this minus sign. And then 2x divided by 2 is just x. So if y is equal to 5 minus x, we can take this 5 minus x and substitute it in for y into the other equation. Okay, so when we take this and substitute it in for y into the other equation, we're going to just bring down the x minus 3 squared. And then plus, in place of this y, we're going to substitute it with 5 minus x. Now, don't forget about this plus 2 here, though, okay? Even though we're substituting for y, we still have this plus 2. So let's write plus 2, and then just finish writing the squared equals 16. Okay, I'm going to go on to the next page just to give myself a little bit more room. All right, so I'm going to say, I know when something's squared, it means you want to write it out twice. So you could write this one out twice, but before you write this one out twice, I would combine your like terms. Not that you have to, but if you don't combine your like terms first, then you're going to have 3 terms you have to distribute to another 3 terms. It's just going to make it a lot harder. So why don't we first just bring down the x minus 3 squared, and then plus, now when we combine the like terms here, 5 plus 2 is 7, so we could write that as 7 minus x. And then we'll bring down the equals 16. Okay, so now, since these are both being squared, let's write them out twice. So we have x minus 3 times x minus 3 plus 7 minus x times 7 minus x equals 16. Okay, and we're just going to double distribute. So when you double distribute this, okay, we wind up getting x times x is x squared, x times negative 3 is negative 3x, negative 3 times x is negative 3x, and negative 3 times negative 3 is positive 9. Okay, now I'm going to bring my addition sign down, and I'm going to double distribute right here. So 7 times 7 is 49. 7 times negative x is negative 7x. Negative x times 7 is negative 7x. And negative x times negative x is positive x squared. And then we'll bring down the equals 16. All right, so now it's time to combine like terms. And you know what? Since we're going to have to get this side of the equation equal to 0 anyway, I'm going to subtract 16 and kind of combine like terms all in the same step. Okay, so the right-hand side of the equation is equal to 0. Now, when we combine our like terms, let's see, we have an x squared and another x squared over here, which is going to give us 2x squared. And then we have lots of x's to combine. We can combine a negative 3x, a negative 3x, a negative 7x, and a negative 7x to give us negative 20x. And then let's just combine these two numbers, 49 minus 16. Oh, actually, plus 9. So 9 plus 49 minus 16. That's going to be positive 42. All right, so now this isn't so bad because all 3 of these numbers are even, which means they're divisible by 2. So if we divide both sides of the equation by 2, it'll make it a little bit easier for us. All right, so 2x squared divided by 2 is just x squared. And then I'm going to take this minus sign and bring it down. And then 20x divided by 2 is 10x. And then I'm going to take this addition sign and bring it right down. And then 42 divided by 2 is 21. And then bring down the equals, and 0 divided by 2 is 0. All right, so from here, we're just going to factor. We're going to come up with 2 numbers that multiply to 21 and add to negative 10. So that's going to be negative 7 and negative 3. And time to make the t-chart. All right, so on the left side, we get x equals 7. And on the right side, we get x equals positive 3. So now we need to find the y values that go along with these. So I'm going to go back to that original equation I made, where I got y by itself. It was y equals 5 minus x. So y equals 5 minus x. And I'm just going to substitute in 7 for the x into this one. So if we do that, we'll have y equals 5 minus 7, which is equal to negative 2. And if we do it on the other side, I'm going to substitute the 3 in for x. So that would give me y equals 5 minus 3, which is equal to positive 2. All right, so here, when x is 7, y is negative 2. So we have 7, negative 2 is 1 point of intersection. And then when x is equal to 3, y is equal to positive 2. So 3, 2 is our second point of intersection. And if you took either one of these coordinates, so if you took this and substituted this x value and this y value into both of the original equations, it would check out. And same thing with this point. Okay, so now you're going to try out numbers 5, 7, and 9 for homework.